All right, so starting off the last two sections of our unit, we're going to go over inequalities in one triangle. The other one will be inequalities in two triangles. It's kind of follow the same ideas. But we have four different theorems we're going to be looking at: the exterior angle theorem, angles to sides, sides to angles, and triangle inequality theorem. All right, so take a look at these individually and see what they are. Zoom in. All right, the exterior angle theorem. We've actually talked about this one before, um, and it's the idea that the measure of an exterior angle of a triangle the measure of an exterior angle of a triangle is greater than the measure of its remote interior angles. So really, again, we kind of talked about this before. We have our remote interior. So if we have like these three angles, we're gonna have, we can call these angle A, angle B, and angle C. Is that this exterior one, right? This one on the outside, angle C, because we're talking about inequalities. Remember, inequalities are stuff like less than, greater than, um, those types of things, right? An inequality is stuff like greater than, right? It's either less or greater than. So the way this works is that angle C, right, in this case is greater than angle A or angle B, since you have to add these two together to get this, right? Since angle A plus angle B is equal to angle C. All right. And again, if you don't remember, in case we looked at it before, right? If you add these two together, right, it's going to equal to whatever C. So since it equals whatever C is, then C has to be bigger than either of those two, right? That's the idea. All right, just something to remember, something to kind of go by. We've talked about this one before. All right. Now for the actual real meat of this lesson, right? What we're actually talking about with this stuff is the sides and angles and the angles to sides ideas that we're going to be looking at. So, all right, sides to, or angles to sides. If two sides of a triangle are not congruent, right? So in this case, if two sides are not the same, then the largest angle lies opposite the longest side. All right. So let's kind of take a look at this and kind of see this all individually with all the different angles and all that, right? Here's my last pen. All right. So if we have the fact, we have this one angle here. Let's call this angle Y. We're going to look at angle X. And lastly, angle Z. Okay. They're obviously not all the same. So if we say that angle Y is greater than angle X, which is also greater than angle Z, right? So we're saying the fact that this is our biggest angle, then the medium, then the small, right? The idea is the largest angle lies opposite the largest side. So it's the same order, right? The biggest side would then be, right, XZ. The medium side would be opposite of X, which would be YZ. And then lastly, the smallest side, and you can actually even see it too, is XY. Right? And so it kind of even works out that way too, right? So again, the largest angle is across from the largest side. The largest side is across from, and since the largest side is also across from the largest angle, that's what's going to show up on this stuff too, right? So again, across from y is this xz. So xz is our biggest one. That's greater than, right, yz, which in turn is greater than, in this case, xy. Oops, I messed up that color. This should be green. All right. So the largest side is across the largest angle. And it also plays the same with if you have the largest side, right? The largest side is going to be across from the largest angle. So let's take a look at that. Look at this one. We can get that one a little bit more quickly because it's the same idea. All right. So again, if two angles of a triangle are not congruent, let's see. Come on. All right. Then the longest side lies opposite. Okay. But yeah, really, it's the same idea, right? We've had it before, but now we're talking about the sides instead, right? Obviously, like the largest side here would be BC, right? And so that's opposite of angle A. So, oh, let's see, there you go. BC is greater than, so in this case, angle A is also greater than. Right? Our next one up would be like AB, which is opposite the angle C. Yeah. AB, which is opposite of angle C. And so lastly, right, the smallest side, CA, is opposite of angle B. So this is greater than, this is greater than, in this case, CA, angle B. Alright, those are all the opposite ones. Oh, and then gotta mark them. This one's tiny. This one's a little bit bigger, and then the largest one would be angle A. Alright. Okay, that's it. Idea. It follows the same idea as what we just had before. Alright, our last little theorem, right? The triangle inequality theorem. So it's actually talking about, so a good idea about how this actually all works. The way a triangle has to work, right, to actually make a triangle is the sum of sides of a triangle is greater than the lengths of the third side. So for a triangle to work, right, for actually to make a triangle, when you add the two smaller sides together, it has to be bigger than the largest side. So the addition has to be bigger than the longest side, right? And so that's the idea, right? That's what we're looking at. That's what we're trying to do. That's what we're getting at. So when you addition of the smaller sides, right? When you add these two numbers together, right? When you add the two lengths, when you add the two lengths of the smaller sides, it has to be greater than that, right? So if you add xy and yz, it has to be bigger. It has to be greater than our last side, xz. All right, there you go. Those are all the other ones, right? So when you add these two together, it has to be bigger than those two, or else it won't make a triangle. And I can show you all that and explain that, right? But there you go. That's all the theorems we're looking at for today. Really, the key ones are these three down here because we already talked about this one up here. All right, sounds great.